Welcome. In this lesson, we want to look at the atom. So, I think from the previous lesson that we had, we talked of matter, the particulate nature of matter. And when we looked at the particulate nature of matter, we were talking about the fact that matter is just anything that occupies space and has a volume and even has a mass. So in this lesson, we want to talk particularly, let's say if we have our matter and then it consists of things that are called elements. If it has elements, right, if we break this matter, we break it, it will give us the smallest units, which are called atoms. So there's something that is very important about these atoms, is that these atoms are responsible for issues that deal with chemical properties. So if we want to study the chemical properties of that part of matter, which is elements, we have to look at the smallest part, which is an atom. So an atom has its own definition, which is our first point. Then the definition is that an atom is the smallest particle of a substance. And others would then have to say that it is the smallest particle of a substance that takes part of a chemical reaction. So the smallest particle that is of a substance that will take part in a chemical reaction is what we know as the atom. So it has its own structure, which means that the structure which is here, we have to redraw. So firstly, we have our nucleus. Then in the nucleus, we have two particles that are involved. We have what are known as the protons, as well as what are known as the neutrons. So the neutrons, they're just neutral, as well as the protons, they are positive. So after that, we then have this shell, and the shell represents an energy level, or where the electrons will be. So going to our second point, it is we say that it is this atom has a nucleus which consists of protons and neutrons, which I have said earlier on. And here we have our nucleus. It has two things, which are the protons and the neutrons. So further on, electrons move about around in the nucleus in electron shells, or energy levels. That's the levels that they are able to move in. So I want you to get this shell not as an eggshell, but as an energy level or a field that is surrounding the nucleus. So normally we would find the fact that in an atom we would find that let's say this one is what we have made to be the nucleus. You'd find that some electrons move in this direction, some electrons move in this direction, and some move in this direction. So you'd find out that these electrons, they'll move in different directions, and then the other one moves in a different direction. But if you have to connect this one and this one and this one and this one, they'll somehow give you a spheric shape, which appears to be like a circle, but it's more of a sphere, which is what is surrounding, causing the electrons to move freely around the nucleus. So on our third point, we also look at the characteristics of the three subatomic particles in an atom. So the three subatomic particles in an atom are, we have the neutrons, we have the protons, as well as the electrons. So here in our diagram, we show that electrons, they are found within the shells, right? So now the first, which is the first one, the first subatomic particle that we will look at is the proton, and we'll look at first which is the first characteristic, sorry, which is relative mass. So relative mass for protons is 1, then also for neutrons it's 1. So on the relative mass, the protons and the neutrons are the same, and then the electron is 1 over 1836, or sometimes you find other textbooks which may say 1 over 1880. It's just still okay. And then we have to look at the second one, which is the second characteristic, which is the relative charge. So for the relative charge, we have our protons having a relative charge of 1 plus 1 or plus, and electrons having a minus or minus 1, and then neutrons basically having neutral, because 0 is neutral. Then the third characteristic is the location, or where they are found. So our protons, we find them within the nucleus. So here is our protons. They are positively charged. Let me have another color. They are positively charged, so we have these ones. These will be protons, and the electrons, they are found within the shells. Here are electrons, and then neutrons are found within the nucleus. Then we have our neutrons here. So the two things that are found within the nucleus be our protons and neutrons. So they're often called nucleons. They're often called nucleons. This word nucleons. So our nucleons, there are two, which is the protons as well as the neutrons. Okay, going further with our notes, an atom has equal number of protons and electrons. So let's say we have 2 protons. If we have 2 protons, which is positive, right, we are also going to have again 2 electrons, which are negative. So the number of protons is equal to the number of electrons. And the total number of the positively charged protons is neutralized with the equal number of the negative charged electrons. So if we have this positive and this negative, the two will neutralize each other. In other words, if we have 2, then minus the other 2, it will be equal to 0. In other words, we'll find ourselves having a neutral thing. So an atom in general is electrically neutral. So another question that may come might be the question you could see, describe or explain why an atom is electrically neutral. So you then have to say that the number of protons is equal to the number of electrons. So the charges cancel out each other, making the atom electrically neutral. Then we go to the other point. So in an atom, the proton number or atomic number is Z. Then the number of protons in the nucleus of the atom, that's the proton number. And also the nucleon number is the total number of protons and neutrons in the nucleus of the atom. So we're saying here we have, for this one, we are saying here we have the nucleus, right? And the nucleus, it has protons plus neutrons. So the whole of this will give us the number which is called what? The nucleon number. So that will be the total. And the nucleon number is the one that we find here on top on A. So this is this one that is up there, A. And Z here is the number of protons, and also it is equal to the number of electrons. So if we have Z, let's say for example Z is 6, it means it has 6 protons as well as having 6 electrons. Remember, we said an atom is electrically neutral, and it has the equal number of protons and electrons. And the other thing is that when you go to the periodic table, this is the representation of what we find in the periodic table. So here the periodic table will find something like this, right? Or normally you then have to find it like this, like let's say X, and then we have our A, and at the bottom left corner we'd have our Z. So normally the periodic table that you'll be given specifically for Zimsec, you find out it has this nature. So let's go on. Whatever revision, I thought there was something else to further explain, but however, let me just end this lesson by also talking about the aspects of the things that you find on the periodic table. So we'll have to have an example. So this is the example of our periodic table. So for example, we can look at here we can look at hydrogen. So our hydrogen, it means that this one is the nucleon number. This one is the nucleon number. Sorry for that. This is the nucleon number, and also this one is the proton number. So if we say the nucleon number minus the proton number, say that's 1 minus 1 is equal to 0. So it means that for hydrogen it has 0 neutrons. So this hydrogen is protic. In other words, it only has